Okay, good morning again. This is Professor David J. De Los Reyes. Okay, my topic for this session will be a long video format, a random topic which is very important under college algebra. Okay, let's proceed. The problem I will be solving, I will try to read it. Problem, solve for x, we are given an equation which is in the form of radical sign. So this the square root of x plus 19 minus the square root of x plus 28, and this should be equal to negative 1. The problem is asking for the value of x. So this is an equation that involves radicals. Okay, let's proceed with the solution. I will write the given problem, the square root of x plus 19. This negative 1 here, I will place it on the left, so this will now be plus 1. This square root of x plus 28 preceded by negative sign, I will put it on the right. This will now be positive, the square root of x plus 28. So for both the left and right hand side involves the radicals, but there is a plus 1 over here. So it will not be a straightforward solution if you try to square it. There is a plus 1 over here. Okay, we try to square both sides. To eliminate the radical sign, we try to square both sides. The square of the square root of x plus 19 will be x plus 19. Because this is a binomial, if we try to raise this to the second power. So there is actually a middle term. And the middle term is twice the product of this times this square root here. So the middle term is 2 times 1 times the square root of x plus 19. Okay? And the third term, because we are squaring a binomial, right? So the square of 1 will just be simply 1 equal to the square of the square root of x plus 28. The radical sign will disappear. So it will just be simply x plus 28. Okay? So after the squaring, there is still a radical term on the left, but on the right, we are already free of radical. So we try to combine similar terms, okay? This x here is plus, and this x here is plus. So if we try to simplify this one, this x here cancel with this. Right? So what remains will be 2 the square root of x plus 19 will be 2 the square root of x plus 19. The constant term on the left will be 19 plus 1, which is now 20. And for the right hand side, since we cancel out this x here, what remains on the right will just be simply 28. Okay? Rules of algebra, try to maintain the unknown on the left hand side. So twice the square root of x plus 19. This 20 here, we put it on the right. So 28 minus 20 will be 8. Okay? Try to make the coefficient of the unknown unity. So we will divide both sides of the equation by 2, or we will multiply this by 1/2. So these 2 here cancel with this. What remains on the left will be the square root of x plus 19. This should be equal to 8 times 1/2 will be 4. Right? Our unknown is still guarded by the radical sign. So to eliminate this radical sign, meaning this is square root, again we square both sides. So square both sides again. The square of, but it is now simpler because the left hand side is only one term now that is involved with the radical. So if we try to square this one, the radical sign will disappear. So it will just be simply x plus 19. For the right hand side, if we try to square it, the square of 4 will be 16. Rules of algebra, try to maintain the unknown on the left and all constant to the right. So x plus 19 equal to 16. So x now will be equal to 16. We put this on the right. Okay, minus 19. or x will be equal to negative 3. That will be our answer. And to check the validity of our answer, we just go back to the given radical equation. The square root of negative 3, the computed value of x, plus 19, minus the square root of minus 3 plus 28 under one radical sign. Is it equal to negative 1? Square root of 16 minus the square root of 25. Is it equal to negative 1? We'll just take the positive root for the meantime. The square root of 16 will be a positive 4, and the square root of 25, by taking only the positive sign, it will be minus 5. And is it equal to negative 1? 4 minus 5, is it equal to negative 1? Negative 1 is equal to negative 1. It is true. Okay. So our answer x equal to negative 3 satisfies the given original radical equation. Okay, good morning from Los Angeles. This is Professor David J. Pelas Reyes.